What is the focus question that we are trying to answer with our lab investigation? Justin.
How do you use the physical and chemical properties of a substance?
We are going to be making some new substances, and one of them's called Oobleck, one of them's called Goop, and one of them's called Glurch. Verb? Piper, what's the verb here that we need to pay attention to in number 2? Observe. So you need to make sure we're going to highlight the word observe, because that's what you're going to do in number 2. I'm going to record my observations in this table that is set up for you. Highlight the word observe and record your observations. First, we're starting with Glurch. Mix the starch and table salt together in the sandwich bag. Okay, so, again, the verb, the action word. Mix, starch, and table salt. Highlight. They typically highlight in a way that I call coloring, because they don't highlight keywords. They highlight the whole entire paragraph or the whole entire page. And for this particular lab, when we were talking about the order of materials, mixing, measuring, first, second, last, those were the key words. And I actually modeled that for them so that they were highlighting only what I was highlighting. And we talked about it. And so I tried to give them a document that they could then take to the lab and truly use and be able to quickly glance down and see those highlighted words that would make that connection for them. The first thing we need to do when we get our materials is what? What did we highlight? What is the very first thing? Number 2, what do we need to do? Observe. And then we're going to record your observations. So, there are 2 hand lenses on each tray, and you have the salt, NaCl, and you have the starch. And shortly you will have the glue mixture. So right now, as you get your trays, please use your hand lens and make your observations about these materials. And is it clear?
No, it's cloudy.
Cloudy, okay. Cloudy, translucent, or cloudy. Is it a liquid or a solid?
Liquid.
What is this?
Solid.
And did you make an observation about the particle sizes?
So you talked about the colors.
Okay. Is this a liquid or a solid?
Well, so like the table salt is really small, tiny.
You tell me. What are you allowed to do? Yes, after you've made your physical observations, you may start.
Like we could put starch doesn't have a shape.
I thought we was doing size.
Starch doesn't have a size.
It doesn't.
No, it doesn't.
It can take into any size. Like liquids can take into any size.
There's no way to say it.
We can't do shape
There is
either.
no size to a liquid.
So we can put it doesn't have size.
Or just put none.
None. That's what I'm gonna put. And then for like the table salt, I'm gonna put tiny.
What are we putting?
Because it makes sense.
What are we putting for white glue mixture?
It doesn't have a size because it's liquidish. All right. So.
Oh, yeah. I thought.
With Daniel, that's it. You think that's it? You better with that? All right. So where is that?
8 1/10
Okay. So to add 1 gram, where does it need to be?
on the 9 1/10.
Okay. There you go. So y'all measure out and what you need to do first is find the mass of the cup.
Which is how much, Emma? Because I cannot see backwards.
Here.
Just put it in this. Here, let's put this in the middle.
All right, can everybody see this? All right, so you got a triple beam balance. You start with the ones. When you get to 10, then you can move this one back here to 10. And then ones. You got that? All right, this goes all the way to 10.
Yeah.
10 grams, right?
Yes.
Do you see that? All right, well, if something is 10 grams, then you start and you move this one to 10. All right, let's find this first. Okay, so it must be more than 10. So I'm going to move this one here to 10 and then add the 1 gram. Did everybody see how I did that? Because it wasn't moving. So I knew I had to adjust this to 10. Now, is it balanced?
Yes.
So it's 10 plus 2.5. So it's 12.5 grams.
Okay. So
Are you with me? Noah, you're not paying attention, dude.
So we got to do it lower.
So if I'm going to add 1 gram of salt here, what does this need to read?
That'd be 13.5.
Okay. So I want you all to figure that out on your own. Okay? The roll test is to try to get the longest, skinniest snake. Okay? You can only roll it on the wax paper. When you get it to the point that you can't roll it anymore and it won't change, you need to take your measurement and record it. Then ball it up in a ball and start again. You do that 3 times, 3 measurements. Okay, why don't you hold the wax paper tight?
Oh, that's smart.
I didn't think about that. Ugh.
Okay, so y'all can all be doing something.
I'll hold it on that side. You hold it on that side, and then.
And y'all can take turns and see about rolling. How many pancakes have you made?
1.
Okay, who made the first pancake?
Olivia.
Who's going to make the third pancake? Are y'all just going around the table, taking turns? Will that work?
Yes, ma'am, it does.
Okay. Okay, how does it say to pancake it?
Squish it.
Okay. And half of the diameter is known as the
Times 3.14.
It keeps shrinking back.
2 pi r is the circumference, or the diameter times pi, either one.
It's when it like shrinks up.
Do the best you can and get your.
Now I gotta roll in a ball. Roll it real.
Wait, 7, 7?
No. 7, 6, 7.
7, 6.
Okay, now put the wax at the bottom of the table. Angel. You know how that. Never mind. Someone throw it off. Okay, well, what's it?
I will. I got this.
Put the wax at the bottom.
Oh, man.
1, 2.
Hang on.
Oh, man. No. Jump.
Based on the information, if you look at each of the mixtures and you look at the ingredients and you look at which test did better, what do you think you could increase or decrease in each one of the recipes to make it even better? So in other words, what is the key ingredient in each one of these mixtures that's giving it that property? So what do you think the ingredient was that made it do so well? Do you think that there is one single ingredient in each one of these that get, for instance, Goop? It rolled. So if I increase the white glue or the borax solution, would it roll even more? Would it roll better? Yeah. In the Glurch, it bounced. If I added more liquid glue mixture or liquid starch, would it bounce better? So what's your plan? What do you think?
We're going to increase the water, and then because
On which one?
the Oobleck.
Okay, so you're going to change Oobleck how? Add more water? And what is your plan? What's going to change about that?
It's gonna make it more like circular. Not circular, because like when you touch it. Because we didn't use all the 75 grams of cornstarch.
Uh-huh.
So if we add more water, then we can be able to use all the cornstarch and then make it better.
What's going to be better about it?
The pancake test is going to be better. Like, it's going to be out more.
So it's going to make a bigger pancake?
Yes.
Okay. All right. So write up your procedures. You're going Goop. All right. So tell me what you're going to change about Goop.
We're going to change the white glue.
What are you going to change about it?
I guess just like put it up to like 60 ml.
All right. So what is that going to change? What property?
The physical.
Which physical property? Well, if you change the amount of glue, what is that going to change about your Goop?
I don't know.
How many mLs of water?
What are you trying to change about it?
Trying to make it roll better.
Okay, so if you add more glue, you're going... Okay, so it's going to be able to roll better. So you'll be able to make it longer or shorter?
Longer.
Okay, write all that up. All right, this group back here, tell me what you did.
We was trying to make it bounce.
No, you weren't trying to make it bounce.
We added how long it rolled, but it wouldn't
more
so
glue to see if
and
it
it
would
make
make
it
it
longer.
Okay, so their ultimate goal was to increase the roll test, and they added more glue to their substance. But what they found is that it now had more of a rubber consistency, and instead of rolling it, it would bounce better. So they actually figured out something. So what's the ingredient that is key to making it bounce?
Glue.
White glue. Very good. All right, write up your conclusion. Do your science tweets. I'll pass out the paper as I clean off your desk. So our science tweet for today. What did you learn from making the new mixture? I was very excited about the lesson in that the students truly made the connections about the inputs and comparing the outputs, the inputs of what the ingredients were versus what the outcome of the test were. I was very excited that even in the classroom, as many examples as I tried to give them of, for instance, crumpling a piece of paper was a physical change. Tearing the paper is a physical change or physical property. The students still had a hard time grasping physical properties versus chemical properties. And in this lab, when they started examining with the magnifying glass, okay, it's a liquid, okay, it's a solid, okay, you know, they actually had substances that they could say it's white, it's a liquid, the particle size is small, medium, large. They really seemed to be able to connect it together. In addition, the inquiry skills, you know, one of our standards in 7th grade for the inquiry is to use the triple beam balance. And I think a lot of times we take for granted that it's a simple device to use for us, but if the students have not had that hands-on experience, they don't get it, you know. And so I was so glad that I they had the time to actually use it and measure out, and things didn't go exactly right, so they had to do it over because of their miscalculations, and that is the way that they learned. It's very easy to have the notion that, okay, I just have to teach my science content. That's all I have time to do. That's what I'm responsible for. But what we miss a lot of times is that without the literacy strategies, our students are not receiving the best of us because they don't understand the concept, the content. They don't understand if they're weak in ELA, then that's going to transform into our science classroom. I mean, they have to have these literacy strategies to get the most of our class and our teaching. And it goes beyond science content. It goes beyond the middle school classroom. These are strategies that they have to be successful, period. As adults entering the working world, they have to be able to use these strategies. They have to have this concept of comprehension and application and knowing how to reflect and work within cooperative groups. You know, that is the world we live in.